Good morning. Welcome everyone to this lecture number 13. Well, in the previous lecture, we were discussing heat conduction. We had seen series parallel arrangement, and we had also seen how to solve questions on conduction. In today's class, we'll be solving some questions on conduction, and maybe we will wrap up this entire topic today with the solving of some questions. Well, speaking about questions, I think I had given you some questions to solve as homework. Have you done that? Yes or no? Did you find enough time in your hostels to do the questions that I had asked you to do? Great. I hope that you were able to solve this. So what we'll do today is solve some questions, and as you can see, and you will realize that the questions are pretty straightforward in a sense that they hardly should take any time. If you understand them, they hardly should take any time. So let us start with some questions. I hope everyone is ready with those questions. So here comes the first question, again taken from one of your sheets. And the question goes like this: a cylinder of radius r made up of a material of thermal conductivity K1 is surrounded by a cylindrical shell of inner radius r and outer radius 2r made up of thermal conductivity K2. The two ends of the combined systems are maintained at two different temperatures. There is no loss of heat across the cylindrical surface and the system is in steady state. What is the effective thermal conductivity of the system? What is the effective thermal conductivity of the system? Will you be able to do this? So I'll give you time. I'll give you a minute to think about it. We have got the answer. Is that? Well, I think we have got the answer, and the answer that I am getting is C. I think that is the correct answer. How do we go about solving this? So we just draw a diagram where even without a diagram you can solve this question. So you have, first of all, a inner cylinder, thermal conductivity K1, the radius is R, outer cylinder, thermal conductivity K2, inner radius R and outer radius 2R. It is very simple, right? Then you have this end and this end are maintained at different temperatures, so you can understand that they are put in parallel. Both of them are in parallel. Yes or no? You can find out the area of the first cylinder, the inner cylinder. You can find out the area of the second cylinder. Then how do you find the effective thermal conductivity? You can find the effective resistance of this system, R equivalent. R equivalent, and this R equivalent will be equal to Ka by L, where K is the effective thermal conductivity, A is the area, and L is the length of this system. Normally, such a question of effective thermal conductivity should not come. Instead of asking you the effective thermal conductivity, they could ask you the equivalent resistance, and that question would be more in line than the question here. Do we understand this? Everyone got this answer? Yes or no? Can I have some raise hand that we understand this? Okay. Let's move on to the next problem, and the next problem goes like this. I'm taking all these problems from the sheet. So after some problems, we might venture into the problems from the last year JEE and all. Let us first solve these problems. So this one and this problem will give you an idea of what will happen if you have 2 slabs or 3 slabs or 4 slabs or 5 slabs put like this. The temperature of the interface of the compound wall as shown in the figure in terms of their thermal resistances R1 and R2. Same question could be used or could be asked in electric current. What is the temperature of this? What is the potential of this point? The potential of this point is this, and the potential of this point is this. In terms of thermal resistance, they are asking. There it could be in terms of resistance of this. Can I have some answers here? And this will give you an idea of what will happen if I have third, fourth, fifth. You can probably use interpolation. What is the answer for this? You have A, B, C, D. What will be the what? What will be the what? What will be the what? The temperature of the interface. What is the answer? I am getting B. Everything looks similar. And in fact, I think B and D are same. They only have changed R1 theta 2. In B, R1 theta 2 is put in the first case, and R2 theta 1 is put in the second case. Actually, B and D are same if you look closely. But the answer is not B or D. The answer is C. I have told you this question, how this has to be done. Yes or no? If I say that the temperature of the interface is T, same current will flow through the slab. So T minus theta 2. If I say T is more than theta 2. Oh, theta 2 is less than theta 1. So T will be less than theta 1. So theta 2 minus T divided by R2 will be equal to T minus theta 1 divided by R1. From there, you can get the value of T. Yes or no? Do we understand what I'm saying? Or shall I solve it? If I say that the temperature of this point is T, whatever thermal current flows in this section, the same thermal current flows in this section. Delta Q by delta T, the same thermal current. The thermal current in the first section, the left wala section, theta 2 minus T divided by R2. That should be equal to the thermal current in the next section. T minus theta 1 divided by R1. Do we understand this? Yes or no? From here, you can get the answer, and I don't think the answer is C. I'm sorry, I made a mistake, sorry. The answer is theta 2 will be multiplied by R1 and theta 1 will be multiplied by R2. That is correct. Even I made a mistake. That is the answer that you will get. So either you say B or you say D, I think both are correct options. Do you understand this, yes or no? Now, if I have this question, remember whatever questions we are doing here, the same questions could be done in electric current. Now, if the question is like this, 6 identical rods are joined as shown in the figure. Points A and D are maintained at 220. What is the temperature of the junction B? What is the temperature of the junction B? All rods are same. So they have same thermal resistance. It's a very simple question. I think you should be able to tell me the answer. Your time starts now. C. I've got the answer as C. Yes, I think I don't know the answer. So let us go about and solve this. How I'm going to solve. Why is anyone muting me every time? I've been muted once. I've been muted again. Why are you muting me? You don't want me to talk? I'll keep quiet. Not a problem. But then you'll have to do the talking. So kindly not mute me. Whosoever is doing this, whether knowingly or unknowingly. If you do something knowingly, it's dangerous. If you do something unknowingly, it's more dangerous because then you don't know what you're doing. So knowingly, it's dangerous. Unknowingly, it's very dangerous. Because then you should not touch anything. Because if you do it unknowingly, you're not competent enough to touch it. Okay. So if I call the resistance of this as R, the resistance of this also becomes R, resistance of this also becomes R, this also becomes R, this also becomes R, this also becomes R. You can find the effective resistance. This becomes 2R, this becomes 2R, 2R and 2R in parallel, it becomes R, right? So this is R, this is R, and this is R. So the total resistance becomes 3R. Do we understand this? It's pretty simple. The effective resistance becomes 3R. I can find out the thermal current. The thermal current will be 200 minus 20 divided by 3R. Do we understand this? Yes or no? Now, whatever thermal current is flowing, the same thermal current will flow through this section. If I call the temperature of this junction as T, this should be equal to 200 minus T divided by R. Do we understand this, bacha? Do we understand this? Can I have some raised hands? From here, you can find out the value of T. R will get cancelled and you will have a simple answer in front of your eyes. I think that is 140. Do you all get this? Can I have some raised hand that we understand this? Great. I hope all of you were able to solve this. And then we have this. I think we have already discussed this question, I think, but still, I will probably make one question of my own and let's see if we can discuss that one. I think again, this is taken from your sheet and the question goes like this. And I think I told you what this thing stands for. I have a steel rod here, copper rod here, copper rod here, and in between I have a copper rod. The question says that I have to find the amount of heat that flows per second from the hotter end to the colder end. The question could be put in a different way. I could also ask you the temperature of this point. Now, I hope all of you understand this. Yes or no? Can I have some raise hand that we understand this? Now, I don't want you to get into complicated calculations because I just want to understand the concept, whether you have understood the concept or not. So I'll just give you, this is 125, okay, I will not change it. This is 0, so I will not change it. What will I tell you is this: the resistance, if I call the resistance of this steel rod as R, the resistance of this copper rod, let us call it as 3R. Let us call this as 3R. So your answer will come probably for the heat flow in terms of R. Not a problem. You can find the value of R. R is K by L or whatever it is. Not concerned with your calculation. I'm more concerned whether you understand the question and whether you are able to solve it. Your time begins now. You can give the answer in terms of R. Or if you want to use the numerical values are given. Length is 10 centimeters, area is 1 centimeter square. Thermal conductivity are given as 850. You can use that values, or simply you can give me the answer in terms of R. Both will suffice. Your time starts now. The temperature of the junction B and the value of thermal current. That is what I'm looking at. Can I have some answers here? Anyone? No one? Shall I do it? Then So if I just write R here, and 3 are here, and obviously 3 are here. And if I look at the the square wala section or rectangle wala section, how does it look like? I think I told you in the previous class, it looks like a BWC. BWC? BWB. Balance Wheatstone Bridge. Yes or no? Does it look like a balanced Wheatstone Bridge? This is R, this is R, this is 3R, this is 3R. So no current will flow in this branch. Do we understand this? Yes or no? We understand this? No current will flow in this branch because the temperature of the section or junction C and temperature of the junction D would be same. In other words, you can also say potential of point C and potential of point D would be same. Do we understand this? Can I have some reason that we understand this? Okay, then this problem becomes very simple. Nothing goes there. So this R and this 3R will come in series. So I'll then just add them. R and 3R in series becomes 4R. This R and 3R are in series. So again, I add them 4R. This 4R and 4R will come in parallel. So the effective resistance will become 2R for this segment. 2R and R are in series. So the effective resistance becomes 3R. Do we understand this? Yes or no? If I now have to find out the thermal current, I know the effective resistance is 3R. Temperature of one end is 125 minus 0, which is the temperature of the other section, divided by 3R. This is the value of the thermal current, which was asked in the question. The only thing was R was not given, so I'm just giving you the value of R. Now, if I ask you what is the temperature of the junction B, can you tell me what is the temperature of the junction B? Fast, fast, fast. Temperature of junction B. Fast, fast, fast. Fast, fast, fast. Fast, fast, fast. Fast, fast, fast. Temperature of junction B. Anyone? What is the temperature of the junction B? I know the heat current is 125 minus 0 or 125 divided by 3R. What is the temperature of junction B? No one has an answer. That would be not correct. I have just told you. So whatever heat current flows, it flows like this, delta Q by delta theta. It also flows in the section AB. So this must be equal to 125 minus T divided by the resistance R. Solving this, we should be able to get the value of T. Yes or no? Do we understand this? Do we understand this? Yes or no? Can I have some reason that we understand this? No one understands this? Okay. Now, moving one step more ahead and probably getting into the level of JEE Advanced, can you tell me what is the temperature of junction C? Temperature of junction C, or for that matter, junction D. Can you tell me what is the temperature of junction C? You already know the temperature of junction B. You have calculated it. Can you now tell me, or even without calculating junction B, you can calculate junction C. Junction C. Can you now tell me how will you find out the value of temperature of junction C? This question could be asked in a different way. Instead of Temperatures, it could be a battery and it could be electric current. The same question comes there. So I'm asking you the temperature or potential of the peak of the Wheatstone Bridge. Can I have my answers? What is the temperature of point C or point D? How will you find it out? The different ways of doing it. So, how can you do this, bacha? Anyone knows the answer? Anyone? No one got the answer. I can't wait till eternity for your answer. So this was the question. To find out this answer, T, what did I do? I found out the effective resistance of this entire system. The effective resistance of this entire system was 3R. I found out the heat current. Heat current was 125 minus 0 divided by 3R, and that must be equal to 125 minus T divided by R. From here, I can calculate the value of T. Very nice and simple. Now, if I call this heat current as I, so if this I is flowing here like this, it will divide into two parallel branches. So same current will flow because both the paths are same. So I by 2 will go here, I by 2 will reach here, I by 2 will still flow here, I by 2 will flow here, and I by 2 will flow here. Do we understand this? Yes or no? Do we understand this? Can I have some reason that we understand this, sir? Yes or no, bacha? Do we understand this? Let me call the temperature of this point as theta. Now it is very simple. I know what is the value of I. So I know the value of I by 2. I by 2, which is nothing but equal to 125 divided by 6R, 125 divided by 6R, 125 divided by 6R. You can easily find the value of I by 2. The value of I by 2 can be written in two different ways. The value of I by 2 can be written in two different ways. I'll give you a second to tell me the first way. The first way is the green way. The second way is the blue way. Can you tell me how you can write the value of I by 2? I by 2 is 125 by 6R. One is the green way, the other one is the blue way. You can write in terms of green way or you can write in terms of blue. I'll give you a minute to think about it. To understand this, that means you understand electric current. A minute to win it. Is there anyone in the class who is trying the question? Well, since no one has given me the answer, so I'll write it from the green path. From the green path, I can write I by 2, which is the current in that branch. From the green path, I can write it as T minus theta divided by R. I hope you understand this. You already know the value of T. If you can put the value of T here, you will get the value of R. If I talk about the blue path, the same thing could be written in terms of the blue path. How will I write it in terms of the blue path? Look at the blue path. I can write the same current in this way. Theta minus 0 divided by 3R. So whether I write it this way, the blue path, or whether I write it this way, the green path, both will land up with the value of theta. In green path, I will need the value of T. In the blue path, I do not need the value of T at all. Do we understand this? Can I have some raise hand that we understand this? It is important for me to know that you have understood this so that I can move ahead in life. Have you understood this? Is there anyone in the class who is listening to me? I don't see you, so I have no idea whether you are in the class or not.
Yes, sir.
So the mic was working, so why was not anyone speaking? Okay, I think now is the time that I must report you guys to the authorities over there that you guys are not being attentive in the class. So you have a mic, but you don't speak, and I keep on babbling, but no one answers. That's horrible. Anyways, may God give you some. Chalo, let us move on to the next question. And the next question is this one. This is taken from JEE. JEE means JEE Advanced. So you can see what type of question actually come in JEE Advanced. So this is the question taken from JEE 2009 plus 4 minus 1. And the question, it is a, what should I say, single integer type question. And the question goes like this. A metal rod AB of length 10x has one end A in ice at 0 degrees Celsius and the other end B in water at 100 degrees Celsius. If a point P in the rod is maintained at 400 degrees Celsius and it is found out that equal amounts of water and ice evaporate and melt per unit time. On one hand, you have water which is evaporating. On the other hand, you have ice which is melting. The latent heat of evaporation of water is 540. We know this. Latent heat of melting of ice is 80. If the point P is at a distance of lambda x from the ice end A, find the value of lambda. This is a question from JEE Advanced 2009. Do you understand this question? I hope you do. I'll give you a minute to solve it.
Sir, we are not getting solve it, sir.
Yes, beta?
We are not getting solve it, sir.
You have only tried for a minute. You should try harder. I will tell you the solution, not a problem, but you don't try. Don't try. Have you understood the question? Yes or no?
Nice, sir.
Have you drawn any diagram?
Nice, chamakra.
Yes, beta?
Chamakra, nice, sir.
Have you read the question? Have you drawn a diagram? कि डायग्राम भी नहीं आ रहा समझ में? डायग्राम कैसे बनेगा? Well, okay, not a problem. Whatever question comes in JEE is a pretty simple one. That is the first thing you should understand. The problem with most of the students is as soon as I tell you that's the question from JEE, you stop thinking and you start thinking that it has to be a tougher one. And once you make the question in your mind tougher, nobody in this universe can solve it for you because you've already given up. This is stuff I can't do it. So you have already given up. Anyways, I will since it is my job to show you how to do it. I will try, and how will I try? Oops. I will try to show you a diagram. And let's see if after seeing the diagram, it makes any sense. Does it make any sense now? Have you drawn this diagram? Do you understand this diagram? Do you understand this diagram, bacha? It is way easier for me to solve the question straight away and not spend much time in babbling. Speak, I lose a lot of energy.
सर
I need
समझ में
to.
नहीं आया सर वो
हाँ
समझ में नहीं आया
क्या समझ में नहीं आया? क्वेश्चन की लैंग्वेज समझ में नहीं आई? Don't understand the language? One end it is ice which is melting, other end it is water which is evaporating. ये समझ में नहीं आया? You have to make me understand what you don't understand. Do you understand the diagram, beta?
No, sir.
Don't understand the diagram?
No, sir.
That means you have not read the question. Please read the question. Please read the question while I try to make sense of this diagram. Please read the question. Tell me what is the question. Read it. Read the question. Can you read the question for me, beta? Can anyone read the question for me? Can anyone read the question for me? Again, repeat. Can anyone read the question for me? Can anyone read the question for me?
एक बार क्वेश्चन बताओ सर we don't have that question.
You don't have this sheet with you, bacha? Okay, it is from JEE. So you have not read the question properly, beta. Okay. If you don't read the question, how will you solve the answer? Yeah. Oops, it's very, very hard. Not read the question. You will not get so much time to read the question, beta. Okay. This is the question. To read the question. As I told you, you only get one chance to read the question. And if you can't read it in that time, you have missed a lot of time. Chalo. A metal rod of length 10x. Now can you draw the diagram while reading the question? Yes or no? Can you do that for me?
Yes, sir. I will
Please do
try.
it. That is how you solve the question, beta. While you are reading the question, you also start drawing the diagram so that you don't have to read the question again, and you put all the things that are in the question in the diagram. And that's how you go ahead. I hope you know it, beta. A metal rod of length 10x has one end in ice at 0 degrees Celsius. Other end B in water at 100 degrees Celsius. A point P is maintained at 400 degrees Celsius. It is found that equal amounts of water and ice evaporate and melt. Latent heat of evaporation of water is 540. Latent heat of melting of ice is 80. The point P is at a distance of lambda times x from the end A of ice. You have to find the value of lambda. Have you read the question and drawn the diagram correspondingly? Yes or no? Yes or no, bacha?
Yes.
Sure? Shall I now move on to the diagram?
Yes, sir.
Okay, sir. I have got the thumbs up, sir. So I will go on to the diagram, sir. I'll go on to the diagram. And this is the diagram, sir. Huh. So what is the diagram, sir? This is your ice hand, yes or no? Say yes or no. This is the ice hand, yes or no? This is the ice hand, yes or no?
Yes, yes.
Yes. The distance of this from the point, this point is maintained at 400 degree. The distance is lambda x. Yes or no?
Yes, yes.
Whatever remaining is the distance between the point and the other end, 10x minus lambda x. Yes or no?
Yes.
Water is kept at 100 degrees Celsius here. Yes or no?
Yes, sir.
Well done, sir. One current I1 flows in this direction. Yes or no?
Yes, sir.
One current I2 flows in this direction. Yes or no?
Yes.
Now, equal amount of water and ice are evaporating and melting. You have I1, you can find the value of I1. You have I2, you can find the value of I2. And may God help you. I will give you a minute, 2 minutes. Let's see who can win this battle of IIT-JEE 2009. Let's see who comes on top. I have full faith that you are going to do wonders with this question. And you will be able to solve this and tell me, sir, we have got the answer, sir. And then sir will be very happy that you have got the answer, sir. Can I expect this, students? That you will solve this, sir, or not?
No, sir.
No, I can't expect this. Is it too much of an expectation? That you can solve this now? I'll give you a minute. Your minute is running fast. Minute is running at the speed of 60 seconds per minute. So that means you have 60 seconds to do this. I1, I2, find the value of I1, find the value of I2, and then you are done. And then you are done. And then you are done. This is a question that mixes, and JEE is all about mixing two topics. They have mixed two topics here. In fact, it is still in the topics of thermodynamics, but in thermodynamics, they have mixed two topics. One topic is conduction, and the other topic is calorimetry. Calorimetry, melting of ice, evaporation of water, latent heat, specific heat. That is calorimetry. So they mix calorimetry with conduction, and I've run out of time because I need to solve one more problem from the JEE, and here comes the solution. Now again, I can tell you how it is done, but instead of telling you how it is done, can you read the solution and let me know how it is done? Do you now understand this? Do we understand what is I1? Yes or no? Do we understand how much is I1? 100 minus T divided by R1. Yes or no? 100 minus T divided by R1. Do we understand I1? Do we understand I1? This I1. Do we understand this?
Yes, sir.
Okay, good. Do we understand what is I2? This gentleman, I2.
Yes.
400 minus 100 divided by R2 or R1, whatever you call it. Yes or no?
Yes, yes.
Yes. Now, what is this I1 and I2 doing? They are evaporating water at one end and melting ice at the other end. Now, the heat required to evaporate or melt, delta Q, or instead of delta Q, let me write it as dQ or delta Q. dQ is M into L. Yes, dm into L. Yes or no? Do we understand this?
Yes, yes.
So dQ by dt, which is your heat current, will become dm by dt into L. Yes or no? Yes or no? Tell me yes or no.
Yes, sir.
Yes, sir. Better I go, sir. Then I1 becomes dm by dt into latent heat of melting. Lm, and I2 becomes dm by dt into latent heat of vaporization. LV. This is Lm, this is LV, this is I1, this is I2. We divide it and we get the value of lambda as 9. Do we understand this?
Yes, sir.
Shall I go slowly again, or is it enough? We know the value of I1. We know the value of I2. I2 is going to, I1 is melting ice. I2 is evaporating water. I1 is dm by dt into latent heat of melting. And I2 is dm by dt into latent heat of vaporization. Do we understand this? Final call. Final call for all of you to get onto the plane
Yes,
from
sir.
Hyderabad
Understand.
to IITs. One plane is going to all the IITs. IIT Hyderabad, oh, you don't need a plane for that. All the other IITs, they're all IITs coming and going, and the plane, the last call. Do we understand this? Yes or no?
Sir.
Pakka, sir?
What?
Pakka या कच्चा वाला सर?
कच्चा वाला, sir.
क्या अभी भी कच्चा है? क्या समझ में नहीं आया भाई अभी? What is the problem? Tell me. Tell me what you did not understand, beta, so that I can make some amends. क्या समझ में नहीं आया बेटा?
मैं समझ
Yes,
नहीं आया
बेटा?
सर मुझे.
Yes, बेटा?
समझ नहीं आया.
आया समझ में ना?
समझ में नहीं आया सर.
क्या समझ में नहीं आया? वही तो पूछ रहा हूँ बेटा. What you did not understand? You don't understand what is I1?
I1 is a current.
You don't understand I2?
Yes.
Then you don't understand that heat given or heat taken in the evaporation or melting is M into L. You don't understand this?
Heat current.
You understand heat current, no? You understand heat current, no, beta? No?
Yes, sir.
Then after heat current, what is remaining? It's just the heat gained or heat lost in evaporation or melting. You don't remember that formula that I told you? Mass
I2,
into
I
latent.
understand. I1, I2, I understand. But this ratio of I1, I2.
Don't understand the ratio of I1 and I2?
Yes, sir. The dm by dt into latent heat of
You have we have not done this formula. Heat given or heat loss for melting will be
Q
m
equal
into
to L.
latent heat of melting. You don't remember this?
Yeah, I remember, sir.
Yes, na beta. So bus we divide it by dt, so it becomes dm by dt here. What is so tough here? What is so tough? The rate at which heat is given will be the derivative of that thing, dm by dt. What is so tough? Is it so tough?
Okay, sir.
No, it is not so tough. No, it is not tough. If I write dq, small amount of heat, as dm into dm into L, because L is a constant, L does not change. So dq by dt has to become dm by dt. Why it is so tough to understand? It is as simple as it gets. Yes or no?
Yes, sir.
Okay then, so I think we have run out of time. So we'll finish our class here. Do we understand this question of JEE Advanced? Yes or no? Yes or no?
Yes, yes.
Good. Now, there are still questions that are given in your sheet. If you can do those questions, only those questions. As you can see, with an example of JEE Advanced, whatever we have learned, the same thing is being used in the question. 2 steps, simple 2 steps, and you were able to do a question of JEE Advanced. So I'll end this class here. The next class, do you want to do more questions, or can we move ahead on to the next topic of radiation? You still have questions left in your sheet. Can you do that for me?
Yes.
Yes or
Yes,
no?
sir. Yes, sir.
Okay. So you do those questions for me. We'll move on to radiations, and when we finish the entire heat transfer, we'll also do one or more questions of conduction. So we'll do everything together. Is it fair?
Clear.
Fair, no? You will get enough time till then to do more questions on radiations. Don't have to do 10,000 questions. You just do the question that is given in your sheet. They will cover everything that can come. So on that note, I would wind up today's class. If anything is still there that you don't understand, you can always ask me. I'll explain it to you once, twice, 5 times, 10 times. Not a problem. I'm here to teach. Okay. So on that note, let us wind up this class. We'll meet you tomorrow. We'll start with radiation. Take care. Have a nice day.